Question 7. A ray of light travelling through air strikes the middle face of an equilateral glass prism. Strikes the middle of a face of an equilateral glass prism. State what happens to the frequency, wavelength and speed of the light as it goes from air into the glass. So the frequency stays constant. I'd say if there are 10 waves per second arriving at the surface of the glass, then none of those waves get destroyed. We don't have new waves created. So there has to be 10 waves per second inside the glass as well. The speed we know reduces. This is because the light travels more slowly through the glass than it did through air. And as a result, the wavelength also has to reduce. The waves get bunched together, but also since wave speed is equal to frequency times wavelength, if frequency remains constant and speed goes down, then the wavelength will have to decrease as well. Part B, the angle of incidence is 30 degrees and the refractive index of the glass is 1.5. Draw a diagram to show the path of the ray through the prism. Calculate the angle between the ray leaving the prism and the normal to the glass surface at the point at which the ray leaves. Now, this is similar to another question that we did. So similar set of reasoning. We've got an initial angle of 30 degrees. We know this bends towards the normal, so this angle will be smaller than 30 degrees. We can use Snell's law to show that this one has a value of 19.5 degrees. Since this is 19.5, we can fill in the other angles on our triangle here. The third one allows us to find the size of this internal angle, which it comes out as 40.5 degrees. Then again, we use Snell's law. The ray bends away from the normal down here, and this final angle should come out as 76.9 degrees.